The Open Systems Interconnection Model is a conceptual 7-layer framework that standardizes networking functions into ordered steps. Let's start at the top. Layer 7 is the application layer. This is the window for users, like your web browser or email app. Layer 6 is the presentation layer. It acts like a translator, formatting and encrypting the data so the other computer can understand it. Layer 5 is the session layer. It opens and closes the communication lines, acting like a phone operator holding the call open. Layer 4 is the transport layer. It chops your large data into smaller, safe pieces called segments and makes sure they all arrive without missing pieces. Layer 3 is the network layer. This is the GPS of the internet. It adds IP addresses and finds the best route for your data to travel. Layer 2 is the data link layer. It organizes the data into frames and checks for physical errors on the local network. Finally, Layer 1 is the physical layer. This is the actual hardware, the cables, the radio waves, and the electrical pulses that carry the raw ones and zeros.
The TCP/IP model. While the OSI model is a great teaching tool, the actual internet we use today runs on a simpler model called TCP/IP. Think of TCP/IP as the practical, everyday version of the OSI model. It squishes those 7 layers down into just 4 layers. First, the top 3 OSI layers are combined into one single application layer. Next is the transport layer, which does the exact same job as the OSI model. It controls the flow of data using protocols like TCP. Then we have the internet layer, which is just like the OSI network layer. It uses IP addresses to route your packets across the globe. Finally, the bottom 2 OSI layers are combined into the network access layer, which handles the physical cables and local network connections. TCP/IP is the true working engine of the World